Hello, my name is Cyril Sadowski. I am an engineer and also a researcher. And today I would like to talk to you about one very fascinating paper from 1997. It's called Creatures, Entertainment Software Agents with Artificial Life. And if you noticed this agents keyword, maybe it reminds you of our modern AI agents, which everyone keeps talking about. And there is a real connection from the year 1997. If you grew up in the 90s, maybe you remember this Tamagotchi era. So these were these little small devices that fit into your hand, and they were trying to simulate kind of real animal behavior. So you would feed them, take care of them, etc. But these were very simplistic algorithms and implementations of real life. But Creatures took it into another level. And remember, these were the 90s. They simulated real chemistry, real biochemistry, real brains, and even real genetics. So I even can show to you what these creatures looked like in the 90s, basically. So this is Creatures 3 with docking station, and Creatures 3 came out originally in the year 1999. And you see these little creatures moving around, going about their life, even talking. But this is not some simple algorithm or implementation of even some simple machine learning techniques. These creatures, these norns as they are called, they are living out their real artificial life. Because behind the scenes, there is actually simulation of, as I said, chemistry, biochemistry, and neuronal activity. So I can even show you this neuronal activity of particular creatures. So let's take this Avila creature. So here she is. She is sitting somewhere around there. Her name is Avila. And I connected these developer tools to that game, to that creatures game. And right here, I chose Avila, as you can see on the left side. And I've chosen the brain tab, so we can see the activity of her brain. I will just turn off these tips. And we can see what she's actually thinking about and how she's thinking. So we can see that right now her decision is to express herself. And I saw she wanted to express herself towards another norm, another creature. So let's wait for a second. And she now wants to push a fruit, which she sees. So somewhere around her, there is probably some fruit. So yeah, so this is the fruit right here. So she is focusing her attention towards that fruit. And all of this was simulated is simulated by an algorithm, a game, an application, which was implemented back in the 90s. And this paper, Creatures, Entertainment Software Agent with Artificial Life, is actually explaining how the algorithm, how the implementation works. This sentence from the introduction for the creatures is particularly interesting. The agents, known as creatures, have artificial neural networks for sensory motor control and learning. This is something with which we still struggle today, because when we want to create robots, maybe even humanoid robots, which would be useful to us, maybe in our homes that could, I don't know, clean up the house, or maybe in the factories, and that maybe they could do some sort of dangerous work, we still heavily struggle to create these robots that would have dynamic enough behavior and online learning capabilities to be able to navigate even mildly difficult environments, which definitely, your home or maybe factories really are. So they in the 1997, they really tried to create some sort of simulation, some sort of maybe a simulation for future robotics, which would enable artificial systems to learn and adapt to real environments. In one of my previous videos, I actually talked about general intelligence and what is required for us to be able to achieve general intelligence in, for example, artificial intelligence or robotics. And I will leave the link somewhere around here to that video. But you can see that even the creators of Creatures game really understood that artificial life and adaptive behavior is not simple. So as I said before, they try to create this environment, this dynamic and interesting enough environment where these machine learning biological algorithms would be testable, and where we could see how to adapt these algorithms so that the creatures or the potential agents, the AI agents, the robotic agents, would be adaptive enough so we can deploy them into the real world. This sentence, adaptive behavior research, is more clearly focused on the issue of studying autonomous agents. Really clearly shows that the researchers were fully aware how difficult studying autonomous agents and giving them appropriate behavior is. So we tried that, or we are still trying that with, for example, self-driving cars. And we are still not quite there yet. And it's basically 30 years later after this paper was published. They basically tried to create these software agents in virtual spaces, right, in this game. And we would call them today AI agents. Even in the year 1997, researchers Cliff and Grant realized that one of the metrics which is and will be really important for autonomous agents to be actually useful is how long and effective they could function without human intervention for extended periods of time. So this notion of AI agents, working autonomously on long-term tasks isn't something new. They knew about it even in the year 1997. But even today, if you look into the most modern research and into the most modern and best AI capabilities, the AIs basically are able to function basically only for a few minutes autonomously without real human intervention. Their main idea how to implement all this functionality into artificial life, so basically creating autonomous agents that would be able to function without human intervention, was basically creating a system which could simulate homeostasis. So homeostasis is basically your base level of existence. So for us, we define it via drive. So for example, you don't want to have the state of homeostasis. You don't want to be hungry. You don't want to be thirsty. You want to be well rested. So you don't want to be tired. So their thought was to be able to achieve this environment which would be able to provide enough information. So basically we would call that reinforcement learning today. To provide enough information for these creatures to survive, they had to create this complete environment with chemistry, biochemistry, etc. And we can even explore that. So you can see here those developers tools that I have right here. I can choose this drive step for Avila creature, and you can see that she has these different drives. So there is this boredom, or maybe she's hungry for different types of food. And as she traverses around the environment, that for example finds food finds toys to play with, those drives will increase, meaning it will basically increase the likelihood that the next time when she is hungry, she will eat food. When she's bored, she will play with toys. So this is the basic idea of reinforcement learning, online reinforcement learning in the environment. And this is something, in my opinion, that we are missing heavily in robotics today. And I think that the homeostasis way of implementing reinforcement learning would be probably the correct and most efficient way how to get real useful robots in the future. Now, as I scroll through the paper, you can see that there is a lot of discussion about how the neural net was implemented. Also, discussion about the creatures and the world itself. So the screenshot that you can see here, this is from the originals, the Creature 1 implementation of all of these algorithms. That's from the year actually 1996. So if you are interested in details, you can of course read through the paper. It's moderately difficult. If you know something about chemistry, neural nets, etc., you will be able to read through this paper quite effectively, but it's not important to understand all the details. One interesting thing is that these creatures could actually learn verb-object language, so you can actually talk to these creatures. So let me give you an example. So maybe let's see whether they would be able to understand when I tell them push dispenser. Yep, and they pushed. So as you can see, they are pushing this dispenser machine, and actually food is being dispensed by this machine. So you can actually talk to these creatures. One more small detail I want to touch on is the neural network, the architecture that the creators, Cliff and Grant, implemented. So they tried to implement these systems in such a way that they would be mostly driven bottom up, not top to bottom. That means that the drives and the chemicals that exist in the environment, so basically the chemicals in the environment are influencing the drives of the creature, so if they are hungry or maybe bored. And then based on the drive reduction or maybe increase, the neural net is learning or disinhibiting certain behaviors. They implemented these systems, these bottom-up systems, to show that even simplistic approach can create very complex behavior. Also, this neural net originally had only 1000 neurons, which is actually laughable when we compare it to modern artificial intelligences, basically our large language models, which nowadays have billions of parameters or neurons. But these neurons in creatures, in this paper, they behave more like real neurons in our own biological brains. Now, you might ask why implementing simulation of biochemistry into a game, into a simulation of neural network activity. Well, basically, the biochemistry served as a loss function, or we would call it as loss function in modern machine learning training techniques. So this biochemistry was simulating the drives that we see here, and the chemistry of a particular creature can be found in this chemistry tab, and you can see that we have all these different chemicals that exist within a creature's body, and it's, for example, water or fat or ammonia, etc. And then from these chemicals, drives are derived, and from these drives, brain activity is derived, and from the brain activity, the actual behavior of a creature is then derived, and you can see it directly in the game. So for example, she drops a flower. Before I end this video, I want to leave you with one of my personal stories. When I was about 11, I read one PC magazine And in that magazine, there was an article about creatures. It was actually about creatures, the first creatures. Okay. And the article was describing how two Norns fell in love. And when one of those creatures died, the other creature actually died of sadness. So this got me really interested in artificial life and in artificial intelligence. And we can see in the statement, the behavior of the creatures is dynamically interesting and varied, and they do indeed appear to learn. So this sentence, I think sums it all up. If you are interested in creatures and maybe understanding how they work under the hood, and you would like to use these developer tools that I'm showing to you right now, you have even, for example, Genetics Kit at your disposal within this development tools implementation. You can find the GitHub repository right here. I left a QR code. And if you liked this video, please share and subscribe. Have a great day.